Hi everyone, we're starting our next chapter, which is Chapter 8 in your MYP 4 book, and we're going to be looking at factorization. So as we saw in Chapter 3, we looked and explored different types of expansion. So we saw difference of squares, perfect squares, FOIL, and the distributive property and so forth. What we're going to be doing now is we're going to be looking at different types of factorization. Now, factorization and expansion are opposite operations. That basically means that one operation undoes another operation. So an example would be, if I took x plus 3 times x plus 4, if I were to expand that, it would turn out to be x squared plus 4x plus 3x, or plus 7x, and then plus 12. Now, if I wanted to go backwards and figure out, so we have, in this situation, parentheses that we are removing. So in expansion, we are removing parentheses, or remove the brackets. When we're looking at factorization, we are going backwards, and that means we are placing the parentheses or the brackets back into the expression. So what does that mean? It means that I'm going to go back and I'm going to look for the two original parentheses or brackets, or binomials in this case, that made up x squared plus 7x plus 12. So like I said, expansion and factorization are opposite operations. So whereas expansion removes the brackets or the parentheses, the factorization process places the brackets back in. So places brackets back in. In the expression. Okay, so let's start by taking a look at taking out common factors. So the first type of factorization that we're going to be looking at is going to be that of removing a common factor. All right, now we know that if we were to multiply a times bracket b plus c, when we go through the distributive property, that means that it becomes ab plus ac. Now the reverse process is going to be called taking out the common factor, okay? So that means that I start off with ab plus ac, and I take out what's common so that I'm left with a, and then the b plus c goes to the inside of the parentheses. Now, if we were to take an example such as 5x plus 15. So here's 5x plus 15. So what I'm going to do with 5x plus 15 is I'm going to say, well, 5 and 15 have a number in common that could be removed. And that number happens to be 5. So 5 goes into 5, but 5 also goes into 15. So that if I take out a 5 and I open a parenthesis, what I end up getting is that 5 divided by 5 gives me 1, but it's 1x, because I have an x still inside. And then 15 divided by 5 gives me 3. So that I end up just getting 5 bracket x plus 3. Now if I were to remove the parentheses again to check to see whether I'm going to get this answer here, then I can do that very quickly. I can say 5 times x is 5x, which is up here, and 5 times 3 is 15, which is there. So it works. I know I removed the correct common factor. Now, what we do is we take the common factor and we place it in front of the brackets. That's basically the gist of what's going on. We take that and we place it in front of the brackets. And the expression inside the brackets is then going to be obtained by dividing each of the terms by 5 that were inside the brackets. So I said 5x plus 15, I had 5x plus 15, and I said 5x divided by 5 gives me x, and 15 divided by 5 gives me 3. Done. All right? So that in general, to factorize an algebraic expression, what we do is we take out the highest common factor and we put it inside the brackets. then the expression inside the brackets is obtained. So we get the expression in the brackets by dividing each term by that highest common factor. Okay, so let's do some other examples. I'll explain this a little bit later on. So let's remove some common factors. So let's just take a look at what some of the factors are. So if we were looking for the factors of 42, for example, all right, well then what we'd be doing is we would be asking ourselves, well, what two numbers multiplied together give us 42? And so I would start to say, well, 1 times 42, and 2 times 21, and 3 times 14, and 6 times 7, and that pretty much covers all our factors of 42. Therefore, I can say that the factors are 1, 2, 3, 6, 7, 14, 21, and 42. Same thing if I were to find the factors of 48. So the factors of 48 are going to be 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. So that the factors turn out to be 1, 2, 3, 4, 6, 8, 12, 24, and 48. I'm sure you did this in grade 6 and grade 7 and in grade 8, so I'm not going to, press on this too much, because you should know how to do this. And above all, you should really make sure that you know your multiplication, because otherwise you're going to find yourself in a bit of a jam if you don't know your multiplication tables. All right, so if we were to look at the numbers, for example, 42, 56, and 63, okay, my question could be, what is the greatest common factor? And what you're really thinking is, what is the largest number that will divide evenly into all of these numbers, 42, 56, and 63? And the largest number appears to be, in this case, 7. All right, so let's take a look at, some other examples, and we'll start looking at, for example, 15 x to the power of 4 y cubed plus 10 x cubed y. Well, taking a look at the numbers separately, certainly the numbers separated from all the variables, the highest number that I can remove between 15 and 10 is going to be 5. So I can certainly remove a 5, and I say, well, 15 divided by 5 gives me a 3, and 10 divided by 5, I've got a plus in between, and 10 divided by 5 will be 2. And then the next thing I do is I look, and I say, well, I've got a 5 here. Now, what's the highest variable I can remove? Well, it would appear that the highest variable that can be removed here would be, well, I've got an x to the 4th and an x cubed. So it would be x cubed is the highest thing. So x to the 4th divided by x cubed would give me an x. So as I was saying, because I'm looking at the x to the power of 4 right now, I'm going to do x to the 4th divided by x cubed, which gives me x, and then x cubed divided by x cubed, which will give me a 1 in that case. So there will be no x here because I've removed the x. All right? And then the last thing I need to look at now separately is the value of the y. Well, I've got a y and I've got a y cubed. So the one thing I can certainly take out, the highest thing I will be able to remove is going to be the y. So that y cubed divided by y will give me y to the power of 2, and y divided by y will just give me 1. All right, so having done that, then I can finally come up with my final answer being 5x cubed y times xy squared in parentheses plus 2. And if I want to make sure that I've done this correctly, I could multiply it out again. And by multiplying it out again, I should be getting the original question. So 5x cubed times 5x cubed y times xy squared will give me, and I forgot to put the 3 inside, will give me 5 times 3 is 15. Then x cubed times x gives me x to the 4th. Y times y squared gives me y cubed, and then 5 times 2 gives me 10, and then 5 times x, and then x cubed times the rest will give me x cubed y. I check now, I've got 15x to the fourth y cubed plus 10x cubed y. It is done correctly. We're going to look at the next question now.